This lecture focuses on the next steps in what we had been talking about in the last lecture, which is in Chapter 2 in Think Like an Architect, the author is discussing these 10 ways that you can develop your seeing eyes when you go to visit buildings. So we want to think about this in terms of the examples that we're looking at here, but also how you might start to develop your own sense of being critical with buildings, examining the building, and this is going to culminate in you going out and visiting a building and writing about it according to these 10 steps. So you kind of want to pay attention to these as you go through and think about how you might look at a building in these different ways. So this is kind of continuing this idea of dreaming and seeing. So when we talk about dreaming, it's not like having a dream while you're asleep, but the dreaming of, if you look at a building, think, what could I have done with this building, or what might you have done differently? Or even if you're not looking at a building, just thinking about architecture in a more creative way. And a lot of people do this unconsciously, even with your living space, and you think, well, maybe I could have done this, or if this were in this spot, this might be a little bit easier for me functionally, or this might look a little bit better. So always kind of having those dreaming thoughts about what you might do with the architecture around you, or in your imagination, and then looking at buildings in a more observational way. So sometimes we look at buildings and people think, well, I like that or I don't like that. And so we want to kind of get away from the I like that and I don't like that and focus a bit more on, what it is that we're being critical about, these different aspects of the architecture and how we can become a bit more analytical instead of, purely subjective and just saying, well, I like that or I don't like that. Maybe asking yourself why. Why don't I like that? Why do I like something else? So the fourth thing that we look at, taking those steps from the book, is training your eyes to understand the structure. Now, we don't expect everyone here to be an engineer, but what you can start to do is notice the structure of buildings and potentially how it is incorporated into the whole architectural scheme. So the first example we're going to look at is the Parthenon. And the Parthenon is a classical Greek structure. This is hugely important both in architecture and in world culture and in world history. And the reason for that is because the Parthenon has basically become a symbol of many different things. It's become a symbol of antiquity. It's become a symbol of the Greek culture, even Greek modern culture and a country. It's a symbol of architecture and the ability to be able to construct something and design something in such a way that is within a certain set of rules that are prescribed by that culture or by that period. And the Parthenon is important in several different ways. As we look at those other steps that were laid out, the first step being social understanding, we want to step back a little bit and understand what was happening at the time. In Greek culture, the idea of order and democracy and mathematics and science were all hugely important, and those values really are depicted here in the Parthenon. But one of the ways they're depicted and demonstrated is through the structure. So again, I don't expect anyone to be an engineer and say, well, this is exactly how this works. But because of the way the Parthenon is constructed, you can start to get an understanding for the structure of it and its structural rules because it is so ordered. So the Parthenon has what we refer to as a post and lintel construction. So the posts are these stone columns, and they're spaced regularly about the entire building, and they're supporting this large stone entablature. So the entablature, it goes all the way around the building, and because it's so visually striking that the post and lintel construction is ordered, it's almost like looking at a table where you can imagine this heavy top, this heavy stone top sitting on all of these columns, and visually it looks supported because it's so ordered. If there were columns missing at the corners, or there were columns, missing throughout, it might not appear so visually stable, but because of the way that it's constructed and the way that it's designed, you can see, okay, well, I've got this set of vertical pieces, and they are spaced in an even or equal way, and because of that, they're able to support a horizontal piece that runs the length of those vertical members, and it appears balanced, it appears to be secure, and both visually and in reality it's structurally sound. Now, we know that it's structurally sound because it's still here. It was built between the years 447 BC and 432 BC, and the couple of architects who were in charge of the design of this worked closely with the sculptor of the frieze sculptures, and the frieze is part of the entablature that depicts all of the scenes and the different figures that were carved along the top of this. And many of those have since been removed, and they're in various places. Some are in Greece, some are in Britain, in the British Museum. But we see that this is really a holistic design. It's like a team of people working together. And Pericles was the leader, the Greek leader, who commissioned and had the Parthenon built. Now, the Parthenon is also part of an overall complex of buildings. And we see here, you can see some of this, but it's on the Acropolis, which is a mountainous site, like a much higher elevated site as part of Athens, and it looks over much of the city. And so the Acropolis, both figuratively and literally, was kind of at the peak of the culture and the peak of the city, and it looked out over this settlement and the civilization. And originally, this was a site that had been used previously, so there were previous temples on this site, and there were previous important structures in the culture. There was actually a previous temple to Athena, the Greek goddess Athena, and it was destroyed by the Persians when they invaded Greece in 480 BC. And so not long before the Parthenon was commissioned, there had been a structure there that had been destroyed. And so this is a new temple to the goddess Athena. And there was, after the structure was built, there was a statue of Athena that was built at the inside, kind of an inner sanctum of the temple, and it was made of gold and ivory, elephant tusk. And later, one of the leaders of the Greek army would start to sell pieces of the gold in order to pay for their army function and army operations. And so over time that was kind of dismantled, but the temple structure remains. The roof structure, which is not there any longer, was painted and very, very vibrantly and colorfully painted wood structure and completed that entire entablature that covered the whole structure. The columns and the details of this are considered to be of the Doric order of classical Greek architecture. Now, when we talk about the Doric order, the columns are the least ornamented of all the classical orders. But what you see, and you can kind of see on the left in this photo, if you're looking at the columns do not have the same diameter as they go up and down. So you can see that the diameter of the column at the top is thinner than at the base. And so we refer to this as entasis. So entasis is this notion and kind of this design idea that the columns are literally designed to be kind of bulging out toward the lower half of the column. And this is, there's a lot of speculation about why the Greeks designed this way, but some of it is visual. And so it appears that you get this illusion optically that the weight of the structure up above is so heavy that it's kind of pushing the columns down and out at their bases, yet it's still visually secure, because even though there's this heavy top, the columns are able to support that weight, not only physically and kind of structurally, but also visually, because they go out at their base, and it appears that everything is getting smaller and kind of rising up as it gets toward the top, so that it's all kind of supported. You don't have anything hanging way out over the edge, or anything that's clearly unsupported. And so entasis is something that we see not just on the Doric order at the Parthenon, but throughout other Greek structures and other classical structures. Another facet of the Doric order is that at the top of the column, it's very simple and doesn't have any fluting or decoration. Other classical orders like Ionic and Corinthian columns tend to have things like leaves and scroll work and other things like that. But the Doric order is very straightforward and just has a very simple top, and the fluting on the vertical part of the columns is consistent and yet kind of comes out with the diameter toward the base with that that entasis in play. Here we see kind of an aerial view or depiction of the Acropolis, and you can see where the Parthenon is. There are 46 outer columns supporting the entablature. There are 23 inner columns, and they were placed in various parts to kind of create this inner sanctum for the goddess Athena sculpture and statue inside. So, when we look at the Parthenon, it really helps us to start training our eyes to see the structure, because this is such a kind of an ordered visual example of something being heavy yet supported. And sometimes we refer to this as compression structurally, where you have a weight pushing down on something, and yet its ability to support that, it's in compression, and yet it's structurally withstanding that. Sometimes you see compression in structures that are concrete or stone, or have kind of heavy or thicker bases or materials. Now you could have that with something else, but this is a good visual and structural example of something in compression, because it's pressing down on those columns and they're able to support it. So we look at another example, but that's a more lightweight structure, both literally and figuratively, where The structure itself is lighter because it's not solid. There are many different pieces of metal that make up the Eiffel Tower. Now, both of these examples are extremely iconic. When we talk about the Parthenon and the Eiffel Tower, many people have seen at least pictures of these or know what they are. And, sometimes with both of these, we see almost cartoon-like depictions of them so much that it's easy to forget how they are actually structured. So the Eiffel Tower, this was constructed in 1887. Construction began in 1887, and it was constructed for the 1889 World's Fair in Paris. And it was, like many World's Fair structures, it was meant to be temporary and became permanent. We see this happen many times with different World's Fairs, kind of at this period and into the early 20th century. This was meant to be a gateway into the French exhibition, and it was to commemorate the French Revolution, the anniversary of the French Revolution. And their idea was that they would keep it for 20 years and then they would dismantle it. And even as late as the 1960s, there was this idea that it would be dismantled and shipped to another site in the world to display it, but that never came to fruition. And part of that was because it was used as a radio transmission tower, and the French saw this as both a functional piece of the tower, and so it was never dismantled. But fortunately for us, it's still existing and is a great example of metal construction and truss construction of the time. And we see that its shape lends itself to being supported at the base, visually, with the four kind of legs of the tower and the arches that make that up. It's as if the force of the tower is pushing down onto the base of it, and its legs are spreading out, but it also appears supported and stable because of that, because it's not, kind of straight up and down, and structurally it works. And also the trussing of all of these metal pieces come together and form a stronger whole. Now, when we look at the actual structure of the tower, this is standing below it and looking back up. The tower is named for its kind of engineer and designer, Gustave Eiffel, and in French it's La Tour Eiffel. But we see some of this trussing, and when we talk about trusses, it's the idea of triangulation and creating individual parts in a triangular fashion that are able to distribute the forces in a way that you don't have to have solid pieces of the material. Now, obviously these are solid pieces as little bars, but this is not like the Parthenon where there are solid stone columns or solid concrete pieces. This is, these four legs of the tower are made up of many different lightweight metal pieces that are fastened together. And these are pieces of wrought iron. At the time, this was referred to as puddled iron because of the way that it was, the ore was created. So they would have this molten iron, and there were bars of iron that they would put into it and stir into this molten bath of iron, and then those pieces would melt into it, and they'd have the correct ore consistency, and so they referred to this as puddling or puddled iron. Now, because it's an iron structure, it's actually a bit susceptible to fluctuations in temperature. So if it's hot, it can expand, and if it's cold, it can contract, and at the top, it can expand and contract up to about 6 or 7 inches, which, doesn't seem like a ton, but, when you're talking about the entirety of the structure, it can expand and contract a bit. It's still structurally stable. It's just depending on the material that you have, and this is a lightweight structure, and there's so many pieces that it has a little bit of flexibility. And because it allows air to pass through, because there's air between all of these pieces, it has a good wind resistance because it is not solid, and it can be taller and allow some of that air to pass through. It still has a little bit of movement when there's high winds, especially at the top of the tower, where the taller you go up, the greater the wind force is. But it's both beneficial from a design point of view, but from an engineering point of view, this is a great example of one of the first kind of trussed engineered towers that we see of this time, and especially a great example of the ingenuity and technology of the Industrial Revolution at play. And this just shows some of the detailing on the base of the tower, and some of this is more decorative. You see the scroll work with the iron, and then some of it is more just kind of structurally functional, where you have these trusses that span the other legs of the tower, and all of those have triangulation within them, and then the trusses themselves triangulate with each other to create this network and framework that supports the entire tower. Okay, so looking at the structure is extremely helpful, and just kind of training your eyes to view the structure and see it. And that leads into the next step, which is determining how the materials are working. One thing that most students who begin to look at studying architecture, even if it's just kind of a cursory examination of architecture, is that they may have been inside buildings their entire lives, but may not have ever thought about what's behind the wall that they're looking at, or how it was put together, or even the materials that you're seeing, how they're actually working in conjunction with other materials, and how they're working to support the overall building structure or the functionality of the building. So this plays out in many different ways, in all different kinds of structures with all different kinds of materials. And again, you don't need to be an expert in how building materials work, but just looking at a structure and thinking about it is the first step. Just thinking, well, how does this work? How do I kind of wrap my head around what's happening with this building? So the first example of this that we'll look at is the Kimbell Art Museum in Fort Worth. And if you ever get a chance to go there, this is definitely worth the trip. So the Kimbell Art Museum is a favorite among architects, but also visitors to the museum for a variety of reasons, but is a great example of how materials and material selection and using them in a specific way has a very beneficial result architecturally. And when I say beneficial, it's just aesthetically pleasing, structurally the design is working with the material to create a more ideal environment for that particular material. And so one of the things that's used on the Kimbell Art Museum is concrete, and you see the concrete in these arches. And you can see it expressed on the ends of these vaulted arches. So these vaults are in succession, and there are several of these vaulted forms that repeat throughout the design of the Kimbell. And the architect of the Kimbell was Lou Kahn, who designed several kind of famous structures throughout his career. This was built between 1969 and 1972, and it had gone through some schemes with working with concrete and looking at how he could get natural light into the structure, and just working with the formation of concrete and figuring out how to get the best result. And an early scheme for the Kimbell showed kind of like a folded concrete plate at the top instead of this cycloid kind of rounded vault form. But because of the way that it could be formed, the concrete could be formed using a rounded shape, they could create kind of a thin vault, this thin like barrel vault, and instead of having a ton of columns at the side, and you see this on the left side where there's this open portico, it only needed to be supported on the four corners because the vault itself acts as a beam. So, when we're talking about kind of looking at the structure and looking at how the materials are working, the arch is taking all the forces that are, kind of associated with the span of that beam and running them down the sides and distributing those forces down through the columns, and then over the entire length of that barrel vault, the concrete is working to span that entire shape or that entire area. And so that idea is repeated in these rounded vault forms throughout. Now you also see there are some little strips at the top of these arches, not in the one that's open, but in the building. You see kind of in the middle of this photo and to the right, these are skylights that run the length of these barrel vaults or these vaulted forms. And what it allows is natural light to come in, and then there are some light diffusers where it reflects off of these light diffusers inside, and then the light hits the rounded form and it's able to spread that light throughout the rounded form without getting direct light onto the artwork inside. So we can see that in the interior, and when you go to visit the Kimbell, the result is just stunning because you see that not only are these kind of light diffusers able to, they have artificial lighting on them as well, but the natural light comes in and just washes the interior surface of that rounded vault form, and it kind of lights that up, but also highlights the concrete material. And because of the quality of the concrete, it's very smooth and it's able to create this reflective surface that also shows the concrete very well. The other material that's used is travertine, and you can see the travertine panels both on the outside at the ends of these vault forms, and you can see at the end of this kind of perspective view where there's a painting on the end. Those are travertine panels. There are travertine panels where some of the other artwork is displayed. There's travertine and wood on the floor, and then some of these other partition panels where art is placed. But just a very clean scheme that repeats these materials in a way that is not fussy or overly heavy-handed architecturally, but allows the material to do its job, and then also creates an aesthetic result that is beneficial to the architecture itself. If we look at this, you see that travertine panel system on the outside. So you've got these metal pieces of the roofing that go over the concrete vault forms, and then you see the edge of that concrete arch expressed on the outside, and then the travertine panels kind of finish it out at the edge. And this picture on the right is a picture of the architect inside the kind of auditorium space, and you see that little sliver of light coming in, and running across the interior of that room. And it's just one of those buildings where the idea is repeated and expressed and reinforced in a way that really lets the materials kind of come to the forefront. You really notice the materials. They're really, doing what they were intended to do and intended to express. Okay, one of the other buildings that we'll look at in terms of materiality is the Milwaukee Art Museum, and this is in addition to the Milwaukee Art Museum. The original structure was designed by Eero Saarinen, who's also a famous kind of mid-century architect. But this addition to the art museum, the Quadracci Pavilion, this is by the architect Santiago Calatrava, and these forms are quite unique to his designs, and so his designs are quite recognizable. They're usually a combination of cables and cast concrete, typically painted white, but have a lot of influence from nature, kind of bird-like forms and other forms. But he's also trained as an engineer, and so this comes through in a lot of the designs for his buildings, because they're quite technical, and the expression of the structure is there, the expression of the materials is there, but he's always kind of pushing what the materials can do based on his background as an engineer. One of the other things that we see here is the use of movement, and it's hard to tell because I have a still image of this, but this kind of bird-like sail structure, it actually moves throughout the day because there's an atrium below, and so depending on where the angle of the sun is, in order to protect that glassy atrium space below, that those sails kind of move in and out and collapse and splay out again throughout the day, and a couple of times a day they'll be in a different position just to be able to protect the interior portion from the sun. So let's look at one of the interior views. This is part of one of the interior views, and you can see that there's natural light coming in, but also the forms that are created are quite organic. And when we talk about organic forms, it's like non-square or non-rectilinear forms. And you could almost imagine this being like a bird skeleton, or ribs or something else, just like a very kind of sculptural form, yet it repeats over and over, and so you can see the technical aspects of the materials, and you can also see here there's some it allows for some movement. On the left, it shows the connection of these kind of rib pieces, and there are these metal pin connections, and they actually are able to pivot a bit. I mean, not a ton, but just structurally, the building is allowed to move a little bit. It's actually on a site overlooking Lake Michigan, and so because of that, there's a lot of wind that comes off the lake. There's some movement just being on the lakefront, and so structurally it's able to kind of use its materiality and use the materials in conjunction with each other. Now, the materials are not expressed in the same way as the Kimbell Art Museum. Here the materials are all working together in conjunction to fulfill their jobs, but they're all painted white. So the architectural effect is different, where the color of the material is not its natural color, and you're not seeing it expressed that way. You're seeing it more in its form and how it's able to function as a cohesive whole. And you see some other shots of this. This is kind of, this picture on the right is from the back of where that sail is as you approach into the museum, and this is in the winter time, so it's a bit snowy. And then the photo in the middle shows that interior atrium space, and it's quite dramatic where you're looking out onto Lake Michigan, and that's the portion where that sail comes over and starts to protect the direct sunlight views. I mean, there's still filtered sunlight that comes in, but it shields the atrium as it unfolds and then folds back up as it's not needed. There's also a pedestrian bridge that is part of this, so you're seeing that pedestrian bridge on the right, and so that those large cables that we see, kind of this white spike coming out and the cables connecting it, that's helping to connect the pedestrian bridge to the museum, so it's part of the whole overall experience. The next thing that we'll look at is figuring out and determining how the building was constructed. So again, we don't expect you to look at a building and say, oh, I know exactly how that was constructed. But you can start to ask those questions. How did those panels get into place? How did the glass get into place? What was it that caused the architect or the designer to make those decisions about the materials, and then how do they fit together? Those are the questions that help to understand buildings sometimes more than any other questions, because if you can start to figure out how the building was actually put together, it's going to help you to understand materials, structure, light, design, all kinds of things. And this is a building that's currently under construction in Washington, D.C. This is the National Museum of African American History and Culture. So it's currently under construction, and these are some shots from that. But there's some very intricate panels on the exterior and this steel kind of porch structure that you see. And this is not the kind of building that two people went out and on a weekend put together, right? This is a very complex structure, and it would be difficult to figure out exactly how they're putting this together unless you kind of watched it go up, and clearly there are people on cranes, putting corner panels in place. But it's also the fun of visiting a building is figuring out how they must have put it together, how they must have taken whatever the design was and then made it into reality, which is a tricky proposition often, depending on what the architect's original intent was. So, sometimes when we look at a building, some buildings are a bit easier than others to kind of figure out, and figure out what it is that they did. This is the Barcelona Pavilion in Barcelona, Spain. And this was designed by Mies van der Rohe. His whole name is Ludwig Mies van der Rohe. And it was part of the German pavilion or German exhibition at the International Exposition in 1929 in Spain. And it was actually, not unlike the Eiffel Tower, was meant to be temporary, and it actually was dismantled after that and then rebuilt later. Because it's really like an iconic piece of modernist architecture. And sometimes people will go there now and they think, well, what's the big deal with this? Because these ideas of, modernism are so prevalent today, and this structure so influenced other architects and generations of designers that these ideas have almost become kind of passé in how prevalent and ubiquitous they are. But when we look at this structure it's easy to tell what materials are what. And it's easy to tell, okay, what's holding what stuff up. And he had this idea of the floating roof. And so the floating roof says, okay, I've got this one single roof plane, and you know, it's continuous, but how is that held up? How did this get put together? And you can almost imagine this like these series of vertical planes, and those are put in place, and then this roof is kind of plopped on top. And, each material of these vertical planes is a bit different. So one has onyx, one has marble, some of them are glass. There are these columns that are chrome, and then these stone pieces that form the floor and these outer walls. So let's look at one of the interior photos, and you can see there's this series of planes, and the idea that you'd have different planes creating different views and also with different materials. So you think, well, how is this put together? Well, some of these pieces are glass, and the steel frame of these glass pieces was formed, and that's possibly and potentially supporting the roof. There are other places where this red onyx and marble are covering the walls, and you can also see these panels of stone that were put together. These are thin panels. Like, marble isn't shown here as like big hunks. These are all kind of sheet materials that are placed together. And these are conscious decisions to have the patterning of that stone come together in those four corners in that particular way. So, just thinking about how this went together, this is also one kind of modernist view was that all of the interiors would be designed as part of the architecture. And so Mies van der Rohe also designed these chairs, and this Barcelona chair that you see here, the white leather chair. You've probably seen many versions of this and many knockoffs of this because it's a very iconic piece of furniture, kind of mid-century piece of furniture that was designed for this pavilion. So this is the Barcelona chair from the Barcelona Pavilion. And then this idea of this shallow kind of pool that the statue is sitting in, this is meant as yet another material. So it's reflecting materials that are surrounding it, and yet the material of the water itself appears to be a separate panel. So there are these horizontal panels and these vertical panels all kind of competing in different solid and void forms. Another example of looking at the structure and how it was potentially put together is at the Thorncrown Chapel, and this is by Fay Jones. This is in a very rural site in the Ozark Mountains in Arkansas, and it's near a town called Eureka Springs, Arkansas. But the Thorncrown Chapel is an example of expressing the material of the structure in kind of an ordered, repeated way, but it was also built in a way that could be built on a rural site. So all of the pieces of this were designed to be, put up by a few people, like no cranes, almost like an old barn raising where they would build the trusses and build this stacked structure on site. So they had these stacks of these trusses kind of from the floor to the ceiling, and they were laid out on the ground and then just tipped up and put into place. And you see that same structure repeated over and over. Fay Jones, the architect, was also an apprentice of Frank Lloyd Wright and worked for Frank Lloyd Wright. And you see some of the characteristics of what we'd call the Prairie School started by Frank Lloyd Wright, this idea of organic forms kind of repeated in the architecture. And this is almost like meant to be blending in with nature. And in some photos, sometimes when you see this, you think that it's an open air pavilion. Now it's glassed in, it's completely enclosed, so all of those pieces at the exterior have glass in between them, in between those kind of truss-like pieces. But as you look out into the trees beyond, the structure of the chapel starts to blend in with the structure of the trees outside, and that's the intent, is that really starts to blend in between the materials of the outside and inside, and the trusses inside and the structure inside almost starts to mimic the canopy of trees. So it's there's less material kind of at the base, and it starts to become thicker, almost like a tree canopy overhead. This was built in 1980, so it's a bit more modern structure. This picture on the bottom that you see is those structural pieces being tilted up into place. So they're kind of being erected one at a time. And again, this is not with like a ton of, you see a little crane holding one of them, but they were lightweight enough where a few people could tip one and hold it into place. And that was part of the intent, because it was such a rural site that they could get it up in between these trees without damaging the environment and the site that it was sitting in.